All right, this is your algebra notes for lesson 5.6 over parallel and perpendicular lines. First of all, you can determine the relationship between two lines by comparing their slopes and their y-intercepts. So let's start by looking at the equations of these two lines that are shown at the left, let's look at the graphs and let's write their equations. So let's look at this top one. I'm going to call it our first one and this one our second one. So let's look at our first line. I see that its y-intercept is at 1. See how it's 1 above the 0? So that's a plus 1. So we've got y equals something x plus 1. All right, and the something x is the slope. So it's going uphill, so it's positive, and it looks like it's going up 1 over 2. Up 1 over 2, let's double check, up 1 over 2, up 1 over 2. Yes, so it's going up 1 over 2. It's rising 1, running 2, and don't forget your x. So our first equation is 1/2 x plus 1, because that's rise over run, and this is the y-intercept. This is your m, this is your b. Okay, let's look at the slope of our second line, the entire equation. It looks to me like our y-intercept is down 2, so it's going to be -2 on the y-axis, and it looks like it's going up 1 over 2 again, up 1 over 2, up 1 over 2, yeah. Okay, so up 1 over 2, rise over run, so it'd be y equals 1 over 2x minus 2 because that's the y-intercept, this is the slope. Okay, so what I want you to notice is that these two lines are parallel. Remember, parallel lines never intersect. So if this one's going up 1 over 2 and this one's also going up 1 over 2, then that means they will stay at the same rate forever, and therefore they will never intersect. So what we've just determined is that parallel lines have the same slope. So if you see them in an equation, if this part is the same as this part, then they are going to end up being parallel lines. You don't really care what the y-intercept is. You only care that the slopes are the exact same, and if so, they will be parallel. So knowing that, let's move down to the next question. It says, let's write an equation of a parallel line. Write the equation of a line that passes through the point 12,5. So this is a very specific point on the graph that it's going to pass through. And we don't know what the equation is, but we know that it is parallel to the graph of this equation. Okay, so knowing what we determined above, parallel lines have the same slope. They have different y-intercepts. So we are not going to have a -1 on our new line, but we are going to have 2/3 as the slope. So here's what I would start by doing. I would start by writing y equals mx plus b, because this is the equation we're going to use. It's in slope-intercept form. We know that the m is going to be 2/3 because it's parallel to this graph that's 2/3. So we're going to change the m to 2/3. We don't know what the b is. We know our one equation is -1, but just like up here, these were two different y-intercepts. So we really don't care anything about this. So we don't know what our new y-intercept is going to be. So we're going to leave it just plus b. However, we do know an x and a y coordinate that it passes through. And so what we're going to do is we're going to borrow this x coordinate and we're going to borrow this y coordinate just for a minute, just to use as x and y so that we can calculate to find our missing variable b. And once we do that, then we can not use these anymore. We can give them back and we'll have our new equation. So let's borrow 12 for x, and instead of x, we're going to put 12. And then let's borrow 5 for the y. So instead of y, we're going to have 5. And let's go ahead and solve this just so we can find out what our y-intercept, our b, is. All right, so 2/3 times 12. 2/3 times 12 is 8. Bring down your plus b equals 5. We're trying to solve for b here, so we're going to subtract 8 from both sides. b equals 5 minus 8, which is -3. Okay, now that we know what our b is, and we know what our m is because it has to be 2/3 since it's parallel, we can put this number and our new b, this number together, and we can make x and y back to x and y. Because we just borrowed 12 and 5 for a second just to solve this. So our graph that would be parallel to this one is y equals 2/3, because it's parallel, same slope, x minus 3, because that's our new b. All right, let's try one more of those now that you kind of know how to do it. If we know it's going to be parallel to the slope of y equals 2x plus or minus anything, doesn't matter. In fact, you don't even care what that is, because all we care about is that it has the same slope. So we're going to start by writing y equals 2x plus b. And again, the reason we're using 2 is because it's parallel. The reason we're keeping it b is because we don't know what our new b is. And now let's borrow this x and y coordinate and just plug it into the x and the y to solve to find what our b is going to be. So we're going to borrow -3 for x. Let's bring down the 2, and these get multiplied, so I always put 1 in parentheses. We don't know what b is, leave it plus b. We do know what y is for now because we're borrowing this -1 for y. And we're solving it just to get our new b. So 2 times -3 is -6. So then therefore you'd add 6 to both sides. B is going to equal 5. So if now we know our b and we know our m, let's put it all together in our equation. Y equals 2x plus 5. All right, let's move on to, instead of parallel, let's look at perpendicular. So perpendicular, just a quick review, perpendicular lines intersect at perfect right angles. So they make 90-degree angles. So let's write the equations of the two lines at the left. So I'll make this line number 1, and we'll make this line number 2. So our first equation, it looks like it goes through right here for the y-intercept, which is -1. And our slope, I shouldn't have put that box there because now it's hard to see, but I think it's up 1 over 2. Up 1 over 2, yes. Always check in a couple of different places just to make sure your line keeps hitting in that spot. So it's up 1 over 2, which is 1/2, and it goes through the y-intercept -1. So it is y equals 1/2, because that's our rise over run, x, minus 1, because that's the y-intercept. All right, let's look at graph number 2. Graph number 2, I want you to first realize it's going downhill, so that's going to be a negative slope. So I don't know what it is yet, but I know it's going to be a negative slope. So I would go ahead and put y equals negative, just to be ready, because sometimes you forget the negative. All right, how steeply down is it going? Let's see. It looks like it's going down 2 over 1, down 2 over 1, down 2 over 1. Yes, it's going -2, because down 2 over 1 is the same thing as just down 2. Anything over 1 is just the whole number. Don't forget your x, and let's see what our b is. This graph crosses the y-intercept way up here at 1, so it's +1. All right, so here's what I want you guys to see. Parallel lines had the same slope. These two slopes were the exact same. Let's look at the relationship between this slope and this slope. So I'm going to go ahead and tell you, and then I want you to recognize it. Perpendicular lines have opposite. Okay, opposite meaning if one was positive, it's going to be negative. If one was negative, it's going to be positive. So this one's negative, this one's positive. So they're first of all opposite, but then they're more than just opposite. It's not +1/2, -1/2. It's +1/2, -2 over 1. We just simplified it, but it was 2 over 1. So what they've also done is they've flipped the equation upside down. They've used its reciprocal. So in order to be perpendicular, they are not only opposites as far as positive, negative, but they are reciprocals, meaning if it was 2 over 1, it's 1 over 2. If it was 1 over 2, it's 2 over 1. And I just simplified it, but you should know that -2 is the same thing as -2 over 1, which is a reciprocal of 1 over 2. Okay, so perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. All right, so let's classify some lines. So first of all, are these two equations parallel, perpendicular, or neither? This one is in slope-intercept form. The y is by itself. Y equals mx plus b. This one is not. Y is not fully by itself. So you can't determine it unless you rearrange it and first get it in slope-intercept form. So first, to get y by itself, we have to divide both sides by 4. So let's divide this whole side over here by 4. All right, remember when you divide two different terms by the same number, you have to divide each of the terms by that number. So negative 5 over 4, I'm just going to leave it, negative 5/4 x, don't forget your x. And then 12 and 4 do divide evenly, so let's go ahead and divide those. So 12 divided by 4 is positive 3, so plus 3. Okay, now let's look at the 2. And remember, I don't care about the b's. I only care about the m's, the slopes. So let's look at the two slopes and see if there's a relationship. We have a negative and a positive, and we have 5 over 4 and 4 over 5. So since these are opposite and reciprocals, the relationship here would be that they are perpendicular. All right, and it says explain, but we can just say because, they have opposite, I'm abbreviating this, opposite reciprocal slopes. Okay. It gives us a couple more. What about this one and this one? So, yay, we're done with this one. It's already in slope-intercept form because y is by itself, y equals mx plus b, but this one is not. We have to get y by itself. So you're going to have to rearrange this one. So to get y by itself, the first thing we want to do is subtract the 4x to the other side. Bring down your negative 3y. I'm going to put the minus 4x first and then the positive 9. So that it can be in slope-intercept form. And then we're going to divide both sides by negative 3 in our last step. Okay, divide each term. A negative divided by a negative is going to make this positive, but I'm still going to just leave it 4/3 x because that does not divide out nice and neat. However, 9 divided by negative 3 comes out nice and neat. 9 divided by negative 3 is negative 3, so minus 3. Okay, now we have two equations that we can look at the slopes. Remember, we don't care about the y-intercepts, so really this part and this part don't even matter. We're looking at 3/4 and 4/3. So this to me is almost perpendicular. So 3 over 4 flip-flops to 4 over 3, so that would be perpendicular, except that they're not opposites. They have to be positive, negative also, and neither of these are negative. So this relationship is none. It's neither. And you can write out the explain, but it's because the slopes are not opposite. They're not opposites, and they're also not exactly the same. Because remember, in order to be parallel, the slopes would have to be the exact same. All right, last one of these. So what about these two? Thank goodness this one is already in slope-intercept form. We don't have to rearrange it, but this one is definitely not in slope-intercept form. So we need to get y by itself. Let's rearrange it by dividing both sides by 6. Y equals, okay, this is like a negative hidden invisible 1. So it's 1/6, negative 1/6. So I'm just going to leave it negative 1/6 x. And then 6 divided by positive 6 is 1, positive 1. Okay, so now let's look at our 2. We have negative 1/6 for this slope and negative 1/6 for this slope. So since they are the exact same, they are parallel. And again, our explanation is because they have the same slopes. Same slopes. Okay, let's look at the back. Writing an equation for a perpendicular line. Remember, perpendicular is opposite reciprocal slopes. Which equation represents the line that passes through 2, 4 and is perpendicular to this? Okay, well, I would start by writing y equals mx plus b because we want it to be in slope-intercept form. And then let's look at what we need that m to actually be. If currently it is 1/3 and we want it to be perpendicular, then we want it to be opposite, which instead of positive would make it negative. And we want it to be a reciprocal. So instead of 1 over 3, we need it to be 3 over 1. So I'm just going to call that 3 because that's the same thing as 3 over 1. Okay, I don't know any of these other numbers, but I can borrow an x and a y from the coordinate that it told us it goes through. If it goes through 2, 4, then that means one of its x and y variables, one of its coordinates on the line will be 2, 4. So we can borrow 2 for x, and we can borrow 4 for our y, just so that we can use them to figure out our b, our y-intercept. So let's do that and let's calculate that. Negative 3 times 2 is negative 6. Bring down your plus b equals 4. If it's negative 6, we're going to add 6 on both sides. B is going to be equal to 10. So if you put it all together, now we're done with the x and the y, we can go back to just y equals, our opposite reciprocal slope is negative 3, x, and our b that we just solved is 10, so plus 10. So what we're looking for is which one of these is negative 3x plus 10. Not A, not B, not C. Yes, D. So our answer to this one would be D. All right, the you tries down here, I really do want you to try. So go ahead and pause the video and try these 4 and then just fast forward and see if you got the right answers. If you're not ready to try on your own, I will work these out really quickly though with you. All right, which equations below have graphs that are parallel? Parallel again means same slope. And then which graphs are perpendicular, which again means opposite reciprocal slopes. So 6 and 6 are the same. So I would say that these two slopes are parallel. And then negative is the opposite of positive, and 1/6 is the reciprocal of 6 over 1. So this one is actually perpendicular to both, I'll just write it out, both this one and this one. Okay. So these two are parallel to each other. This is probably not the best way to do it, but that's okay. These two are parallel to each other, and the negative 1/6 is perpendicular to both of these. All right, number 2, write an equation that is parallel to this one and goes through the point negative 3, 1. So parallel means same slope, so I'm going to start by doing y equals mx plus b, but instead of m, I'm going to do negative 4 because I know it needs to stay negative 4 because parallel is same slope. I'm going to borrow 3, negative 1 for my x and y just so that I can calculate the b. So I'm going to borrow negative 1 here and 3 here and solve it. That would be negative 12. So therefore I would add 12 to both sides. And b would be equal to 11. So the entire answer is going to be y equals same slope, which was negative 4, x, don't forget your x, plus our new b, which is 11. All right, same thing down here, except this time it is perpendicular. So I'm going to write y equals mx plus b, except instead of m, I'm going to use the opposite reciprocal slope. And if you guys didn't know what's in front of the x, if there's nothing, it is a hidden invisible 1. So what's interesting is if you have 1 over 1, its reciprocal is also 1 over 1. So it's just going to be 1 over 1 again. However, it's negative because the opposite reciprocal would need to be an opposite of positive. So negative 1, x plus b. And again, I'm going to borrow this x and this y to plug it in to find my new b. So I'm going to borrow negative 3 here, and I'm going to borrow 2 here. So this would be negative 2, which means I would need to go back and add 2 to both sides. And then b is going to be negative 1. So my new perpendicular equation would be y equals negative x, because that's negative reciprocal, opposite reciprocal, and then minus 1 is my b. All right, and then the last one, just tell whether the two numbers in each pair are opposite and reciprocals. So negative and positive, that's opposite. 2 over 1 and 1 over 2. So this is yes, because those are both opposites and they're flipped reciprocals. 1/4 and 4 over 1, these are reciprocals, but they are not opposite. They're both positive, so this is no. And then these are opposites. One's positive and one's negative, but one was not a reciprocal of the other, so this is also no.